Dear student, today we will discuss about lenses, their nature and reflection and refraction through lenses. We know the concept, but there is a lot of confusions. Let's clear that. If we just see here, I've just tried to draw upper medium as a rarer medium, lower medium as a denser medium. And we know that if this is normal, whenever incident ray is moving from rarer medium to denser medium, it moves towards the normal. This is angle of incidence, this is angle of refraction, this is incident ray, this is refracted ray. Simple refraction. Now since the ray follows the path of reversibility, if I make the ray to incident from this side, then it will emerge on this direction. That means whenever ray goes from denser medium to rarer medium, it will move away from the normal. That is a simple concept of reflection which you already know. And that concept will apply here. The normal question student when asked why the convex lens converges and concave lens diverges, there are a lot of confusions about it. But to see how simple is the concept, let us try to show these red lines as a tangents at the respective points. May not be geometrically that precise, but they are representing tangent at the respective points, and the dotted lines are representing normal at the respective points. You see, when this case of convex lens, when the incident ray meets at surface at this particular point, assuming this is tangent the corresponding normal, we know that you are going from rarer medium to denser medium. So ray has to move towards the normal. So this is my normal, this is my incident ray, it has moved towards the normal. By the time it reaches here, on this surface, this is a tangent, this is a normal. Now we know we are going from denser to rarer medium. So ray has to go away from the normal. So this is my incident path and now it has gone away from the normal. What happens finally is, because of this refraction at two surfaces, the incident ray which is along this direction emerges along this direction. And you can clearly see it is converging towards the principal axis. The point where it converges is called a focal point. It is very clear that shape of the lens exactly decides the lens is going to converge. Same funda is applied in this concave case also. This is my incident ray. Assuming this is a tangent at this particular point, this will be corresponding normal. Now going from rarer medium to denser medium, your ray will move towards the normal. So instead of going straight, it will move towards the normal. So this is my ray inside the lens. By the time it reaches here, you can clearly see if this is my tangent, this is my corresponding normal, then the ray has to move away from the normal. So since you are going from denser to rarer medium, so it is my ray meeting at this surface, this is my normal, rather going straight, it moves away from the normal. What happens? The ray which is incident in this direction actually emerges in this direction. It is very clear that the ray is being diverged. So this is called diverging lens, this is called converging lens. So one should simply understand actually the shape of the lens which decides whether the lens will be converging or the lens will be diverging. Nothing special, one should know that there is a refraction here, it is from rarer to denser, there is a refraction here, it is denser to rarer, there is a refraction here, again from rarer to denser, there is a refraction here, again from denser to rarer. And whenever you go from rarer to denser, you move towards the normal. Whenever you are going from denser to rarer, move away from the normal, and this characteristic makes the light to converging. Similarly, here you are going from rarer to denser, so ray will move towards the normal. When you reach here, you are going from denser to rarer, so ray will move away from the normal. As a result, the ray diverges and the ray converges. Simple concept of convergence and divergence. It is very clear that shape of the lens and hence refraction into two surfaces decides either it will be converging or it will be diverging. Now, intensely, the ray which I have taken is monochromatic, so that I can just see the refraction part. By chance would have taken a chromatic, that is a white light, then I would have got 7 colors here because of dispersion, and then 7 more colors here. So from one focal point I would be getting 7 focal points. Similarly here if white light is being taken, instead of single focal point, we'll have 7 focal points. Now, as for the dispersion is concerned, is fine. But as for the refraction is concerned, what we assume is, what we expect is that if the rays incident in this direction, it should get focused at a single point rather than at 7 different focal points. If it happens at 7 different focal points, then the problem in the lens is called chromatic aberration. It's not good for the lens. It has to be removed. Anyway, if you go further, power of a lens is defined as 1 upon focal length, provided focal length is taken in meters. You have to be very careful that focal length has to be converted to meters. So if focal length is assumed 25 centimeter, then power will be 1 upon f. Power will be 1 upon 25 is in centimeter. When I divide by 100, it converts into meters. It becomes 100 upon 25, it's 4 diopter. So lens having focal length 25 centimeter, its power is 4 diopter. Same concept can be applied to concave lens as well. I hope you understood everything. Thank you.